Oh, we have 0.0 watts outside. What is going on here? Yes, my friends, we have fully charged the battery today at this very cloudy and rainy day. We had some rain this morning. Now it's a bit better, but we managed to fully charge the battery. I actually told my wife not to turn on the air conditioning inside the house because I needed all the energy here to fully charge the battery. I wanted to show off that you can still recharge your battery in cloudy conditions. So, goal achieved. Yeah, all the charge controllers are in float mode for quite a while now. And you can see the voltage is slowly going down from 55.2 absorption voltage to 53.6. And then the solar will kick in if there is any, because it's already 5:15. So there may not be much left in solar production today. But this doesn't matter. This is just the introduction. Welcome back to the Off-Grid Garage here in sunny, kind of sunny Australia here. Fully charged the battery today. Very good. End of March 2023. And in today's video, we wanna do some work here on the good old PowerWall. Right, we haven't done any work on this PowerWall because it was mainly ready, but now you can see I have already taken off the lid of this duct here, because I want to replace this switch here with this switch here. They look basically the same, but they are not. Let me show you this. Why is this in plastic? This is the switch we have installed already. And this is the switch I want to install. Do you see the difference? Exactly. This is an on-off switch, and this is a changeover switch. See, position 1 off position 2. Now you would ask, why would you do that? Why would you put the DC connection to your inverter onto a transfer switch, you know? Well, the main reason is these batteries are full here as well, and I wanna connect this inverter to these batteries here and see, well, we want to do some testing. It is I'll explain this to you later. So, okay, replacing the switch, right? Taking this switch out, put the other one in, then we've got the third contact, and we can connect this battery here as well. There is a slight problem. Let me show you. This is the switch we have. This is the switch I'm going to put in. So we've got the output, we've got battery number 1 and battery number 2. And here we've got only a breaking contact in between, so it doesn't matter which way around we connect these ones here, right? But this one is of course important because this one needs to be our inverter, and then we switch to number 1 for our battery shelf and number 2 for the ZEPLOS and QSO battery connected from the PowerWall 2 or 2.1 or whatever it's called now. So this is the contact which goes to our inverter, right? So if I hold this one the way it comes in, see the contact, the terminal where the inverter plugs in goes on the other side over here basically. So this cable here going to our inverter positive needs to connect on this side of the switch. No, this is not possible, right? This is not possible. The other positive comes in the duct and goes into the switch and connects on the other side of this switch. So this would be exactly, well, this position here, but I cannot connect the battery. This needs to be the inverter. So as you can see, all this doesn't work. We have to put this changeover switch on the other side. So we're taking this one off and putting this on the other side, because then we can use this terminal, which is our inverter terminal, and just use this cable, bend it over to this side, connect to the terminal, have this terminal connected to our battery shelf, and the bottom terminal there, which comes straight out under the switch, goes then all the way down into this duct, right? So we just need a piece of duct here in between, and we have bridged the two systems together. Well, not really, because it's a changeover switch, so I can use either this battery or the other battery. So we have to do some cutting and some filing here and drill all these 4 holes, which is a total nightmare, because if they are not lining up 100% here, you can't get them in. So first thing we need to do is take out the fuse here of our positive, because these inverters are connected via a fuse, not via a DC breaker. It's a 200 amp mega fuse, and thankfully I have labeled them inverter number 2 which is our Phoenix inverter. Now let's test this one. Yeah, this one is turned on. It's kind of in standby or something. So we just turn this one off completely. Capacitors inside, keeps it alive. Yep, now it's dying. That's it. So this one is dead, but we still have the supply obviously connected to the switch here. Okay, so we can now slide the acrylic isolator over on the other side as per our design. That was really a good idea from one of you guys. So now we have total access to the positive and negative bus bar there. Take off the fuse cover. There's on a 200 amp fuse in it. It's 13 millimeter. So, and because we are not going to work on the negative here, I am covering the negative bus bar with just an old shirt here. So just in case something happens and we make a short or something, there's no way we can do one. There's no way. Okay, I can take this one off. Oh, how do I? Oh no, that's enough. Actually, don't need to take out the fuse. It's enough if I pull off this cable on one side of the fuse, of course, because this is the one which goes to our inverter. I was just wondering, because the bus bar is on top of the fuse, so I need to take off the bus bar to replace the fuse, which we probably will never do. Perfect, okay, we are already done. Well, we need to connect the negative as well from the Ziplo's batteries here all the way up to the Phoenix inverter, right? So we need to run another negative. So we basically connect the negatives of both batteries, the Ziplo's battery and the battery shelf, together. I thought about this for a long time and I cannot see an issue, because as long as there's no connection between the positive of one battery to another, there's no way for any current flow or something. It's like two batteries negative connected, and then I connect my load to either this battery or the other one. Never at the same time. It's not possible. The switch doesn't allow it. I was just going to figure out what size of nut that is. And I've got a 15 millimeter spanner, which is not the right size, but a 14 millimeter is too small. So this must be some American Imperial pre-dinosaur size again. Okay, it's still okay. But it's definitely not 15 and not 14, something in between. Someone with a lot of horsepower has tightened this nut. Wow. There's no way, if I turn it around and put it upside down or something, that it actually fits with any of the contacts. So the only option I can see is to put it in this corner here and forget about this side. We haven't drilled holes in this PowerWall here for quite a while. It feels so good! M5 tab. See, that's how it goes. And then this cable needs to go into this duct and over there. This one goes straight down to our Ziplo's battery. And this needs to be open to connect to our inverter. Dinner. I'll be right back. I'm back. We had one Jägermeister after dinner. One. Now I need to bend this cable the other way so it goes into this switch box. Nah, it'll be fine. It'll be fine. Okay, let's do it. So, and the cable from our battery shelf now needs to go up here and then connects to this bolt of the switch. So we need to cut the cable, and luckily I have two 70 by 10 ring lugs left. So we have to crimp a new one. That is very tight. Again, I'm using a 50mm die for a 70mm ring lug. But that looks pretty good. I tried one 50mm on the top and a 70mm on the bottom here, but I didn't like the result either. So 250 is the way to go with these ring lugs. They are long enough for two crimps next to each other. Gives us maximum crimping. Yeah, pretty nice. Heat shrink. Hey, let me know in the comments down below if you have bought a pink heat gun as well. And what is the name? Oh, nice. Nice. It fits. It is tight, but it fits. Okay, so far this is my battery number 1. And connected to the inverter. Off. Or battery number 2 connected to the inverter. Well, have you ever seen such a piece of duct? Precisely manufactured to fit the off-grid garage. Well, it is a temporary. You know, there's nothing more permanent than a temporary setup. There we go. This is our bridge. We are not connecting the batteries yet. So, and here's my template. So it fits perfectly. 2 cables in here. Alright guys, I think we have done all the mechanical parts so far. We have also reconnected our battery switch here to the old battery shelf. The battery shelf. And we will do the rest of the cabling to the link speeder tomorrow. It will take a bit longer because I also want to build in a little switch here. Well, I'll tell you more about this tomorrow. It will be in the same video, so just wait a second or two and then I'll be back. And you know, alright, have a good night's sleep. See you in 2 seconds. And I already have some cable here for the switch. Strip this off. Okay, so this is a 6mm cable. And we are going to solder this onto the switch. Guys, I'm of course just kidding. Calm down, calm down. I'm not using a 6mm solid cable on such a small switch. But in one of the last videos you gave me a hard time because I used a 0.7mm cable on this switch here. And many comments were like, Andy, you cannot use such a large cable on such a tiny switch. It will destroy it, it will fall apart, which it did, but not because of the cable I've used. And don't solder it too long because it melts the contacts inside the switch. And people have even sent me emails with instructions how to solder correctly. Well, I must admit I'm soldering for over 40 years, so I probably... yeah. But I appreciate your advice. Thanks. Guys, welcome back to part 2. I told you it's only a few seconds. Oh, what a stressful day. Ah, jeez. Okay, so in today's video, in the same video, we want to connect now the cables to our Victron link speeder. But before we get started, I want to show you something over here. So I'm recharging this 12-volt Müller battery here at the moment with my power supply on 14 volts. It still takes 1 amp. And I want to show you the app here and the cells, how imbalanced they are. 191 millivolt deviation we have. And Interesting is this one has a built-in active balancer which is permanently connected, and as you may remember from a previous test, we fully top balanced the battery here to under 5 millivolt at 3.6 something volt. So it was fully top balanced, and then I have used it for maybe half a year now, and now it's the first time I'm fully charging it again, and the battery is absolutely imbalanced. Cell number 3 has just crossed the 3.4 volt mark, and cell number 2 is almost at 3.6 volts. And now the balancer has all the work again to top balance the battery. So it is really not a good idea to keep the active balancer connected all the time. Even people always tell me in the comments they have it connected and it doesn't matter. It really does matter. We have tested this multiple times, and it just happens again here. So I'm showing you again, leaving a balancer connected all the time causes 190 millivolt deviation. When you fully charge, we are at 93%, we are not there yet, but already huge deviation. So don't do it. Don't leave your active balancer connected with lithium iron phosphate. It's different for lithium ion or other chemistries. But lithium iron phosphate, don't leave your balancer connected all the time. So, are you happy with the choice of cables? Okay, let's just make sure the cables are still tight in these terminals here, because they are so tiny. That's why I wanted to use the 6mm cable. It's far nicer to work with. I'm just kidding. So now I have to determine which way I want the switch to switch. So this is on. On should be all the way to the front. So this way, okay. Yeah. Oh God, these tiny nuts. That is totally nuts. What was it again, like a 7mm spanner? Well, I even have a 6mm spanner. There we go. So, this is done. So there you can see it again. So I've paralleled the switch to our contactor in the multiplus. So either this one closes, or we can close the switch manually now to turn on the Phoenix. So and then we can actually see the multiplus working in pass through as well, which means it doesn't add any extra energy. Only this one operates here and takes care of all the load. So it's a different mode we can operate the Phoenix inverter in now with this little switch here. Yeah, this is all part of the project. Okay, back to our bigger cables. Shit, there are cables everywhere. So my initial idea was to use some Anderson connectors to connect the inverter. Then I plug it into this battery, or I plug it into this battery, but I didn't like the idea to cut the 70mm cable here and put an Anderson connector on it. It was a bit messy, so I thought a changeover switch is much cleaner and makes more sense and is easier to operate. And we will use a 35mm cable to connect from the Victron PIDA to our Phoenix inverter up there. Because we have a 100 amp fuse installed, and I have no problem to use a 35mm cable with that. So negative goes from down here all the way up here over the bridge, all the way up here, and needs to be connected to the same terminal as the inverter. So I know it is not designed to take two ring lugs here, so we have to see how this works, because this stud here is not long enough. Well, these are the ring lugs I'm usually using, the bell mouth or flared ring lugs from Blue Bar Industry here at the Sunshine Coast in Australia. Really thick copper material, long enough to crimp them twice. And because the delivery hasn't arrived yet, I was forced to use these ring lugs here. They are 35 by 8 as well, but look at the material, right? Look at this. Yeah. And they're only half the length And I have to use a 25mm die in the hydraulic crimper to make it actually work. So this will be a permanent temporary solution as well until these ones arrive. So I leave the cables a bit longer and then crimp these ones onto the cables much better. Okay, so this goes down here into the duct and this way, and up. We cut it roughly over here, maybe a bit longer. Oh, you can't even see. So we cut it here. I'll leave it a bit longer because I have lots of slack down here in the cable duct to hide the excess cable. I go rather a bit longer. Okay. And it is so easy to feed in these cables into these ring lugs here. Amazing. Ooh, I almost did a bad mistake. Because this one needs to be 8mm as well, not 10. And this is the absolute pain in the ass. With a straight ring lug in this size to get all the strands inside. But then again, 25mm. I hate this. Okay, so let's have a last look at the cable length and also the position of our ring lug. If I would crimp it like this now, it's not the right orientation to our terminal up there. I need to turn this around like this, so I don't need to twist the cable until it fits to the terminal. There, that's better. And I'm not going to use any heat shrink at the moment here because I want to replace these ring lugs again with the proper, better heavy-duty ones once they arrive. So we leave this unheat shrinked. Okay, so before I connect the negative of this battery to the negative of this battery here, we want to measure the voltage difference between here and there. Just want to see if there's any potential difference between the two. I'm not expecting it, but let's measure it. Light. There you can see it. Okay, so we've got a voltage difference of 0.3 volts, so there's no potential difference at all. Okay, I'm still careful. So this is definitely not designed for taking two ring lugs, but we had this before, if you remember, in the electrical cabinet. We had two ring lugs connected to the same terminal as well. Okay, I'm setting this to 8 Newton meters. Yeah, I mean, it is not too bad, you know, it is... There's a copper spring washer under the nut, which is very, very thick, and I left the spring washer away here. And this gives me enough meat, so the actual stud is actually flush with the nut now. So it's good. So you could ask now, why do I have a 70mm cable here for a 3 kilowatt inverter while a 35 is totally sufficient for that? Well, as you can maybe see, this is per design of our PowerWall here. As you can see, the ducting for the AC is exactly the same as over there. So we can easily replace the Phoenix inverter here with another multi-plus and parallel them. And this is the reason I used 70mm cable. But to operate this inverter here, a 35mm cable is totally sufficient. So negative successfully connected between the two batteries, and now the positive from here to our transfer switch. So here we don't need to measure because our switch is turned off here, so there's no way that we have any contact to any of the sides at all. So we can just connect it to the positive of our battery and nothing is ever going to happen. And again here, a permanent temporary solution until the other ring lugs are there, and then I replace them again. Okay, this is definitely my worst work on the PowerWall ever. So it can only be a very temporary solution. This is only for testing purposes now. I don't like this at all. This is all crammed in here. I probably should have used some corrugated conduit or something going from here down here somehow. This is not a good solution here with a cable duct on top of that. Total f here. Potentially fix that. See, the lid is not original. This is like a cream white, and this is a white one. I didn't have a lid anymore for the 50 by 50. So this is from the 50 by 20 or whatever that is. And the lid doesn't really fit on. Anyway, we've got it done. So number 1 is our battery shelf. Number 2, Seplos and QSO batteries down here. And people are also asking under my videos if I still pre-charge the capacitors inside the inverter here when I turn them on. I'm not doing this anymore. I just turn the switch. I only do this on my workbench when I use the 12-volt inverter. And I've never seen anything like a pre-charge resistor installation in any of the commercial installations so far. So there's just a main switch for the inverter, and that's it. Okay, without further ado, let's turn it on. It is on. Inverter is running. Okay, this is now running from the Seplos batteries. There we go. Multiplus has just switched over to mains, which is this one here. And now this one is being powered by our Seplos batteries. Here, the lights came on, and we can see we've got negative 1.5 amps, negative 2 amps, and negative 1.6 from the QSO. So they're all feeding now our inverter up here, and this one is still powered from the off-grid garage. So, and by turning off this switch here, we should be able to, yeah, then the inverter turns off and the Multiplus switches over, and now the Multiplus is our main source of power. And this one is off again. Well, it is on standby, you know. So if the Multiplus needs more than 3.5 kilowatts, it turns this one on automatically. But we can also do this by hand now, just with this one, and it turns on now. That was the main purpose of putting this switch in, because I want to do some testing. Yeah, and now you can see the Multiplus is on pass through, and the 238 watts, which we are using at the moment here, is solely coming from the Phoenix, from our Seplos and QSO batteries. And basically nothing is coming from 16 watts. I think this is the standby of the Multiplus only. And now we've got a limit set of 10 amps of the Phoenix inverter. So this one does all the work until 10 amps, 230 volts and 10 amps. And if it needs more power, this one will add additional energy up until 6 kilowatt total system power. So we are very flexible now where the power is coming from these batteries here, which we want to test, or from the main battery. We can have this one as an additional power option, or as the main inverter, and this one is only additional, or the other way around. That is pretty cool. All right, guys, so far I would say everything is working as I want it to work. We are not looking at this situation here with the cabling. Man, this was pretty cool. Really building something here on the PowerWall again in the off-grid garage. It's like, it feels like in the good old days. And we should do more of these projects again, more of these building stuff, do-it-yourself stuff and everything. We should actually do a really large project again together, right? Actually, there is one coming up. A really big one. Yes, a really big project here in the off-grid garage. Coming up over the winter period. We will build something big, something huge, something large. Well, I really didn't miss this tool explosion, right? Look at all this mess. More tools over here. And because it is already 10 PM in the night again, thank you so much for watching. Thanks for all your great support here on the channel. Thanks for all your amazing donations. And until the next video, when we do more testing with the PowerWall here, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye. Before you go, I actually got another delivery today, but it is not a QSO battery. Not QSO. Look at this.